the integral of x cos x. Now, this has a product in it, and there's no clear and obvious substitution, so it's a good candidate for integration by parts. The rule for integration by parts says, maybe I should write that at the top, the integral of u v, whoops, I can't even write it right, u v dashed is equal to uv minus the integral of v u dashed. So I'm looking for a substitution I can make, call one of these u and the other v dashed. Which way should I go? I want u to be easy to differentiate and v to be easy to integrate. Well, I can do either here, but this will be much simpler if I differentiate it. This will make almost no difference. So let's say u be x and v dashed cos x. Then u dashed is 1 and v is negative sine x. Now you notice we don't worry about writing the constant here. We have integrated, but we don't bother writing the constant because the constant's going to come out in the wash at the end. So here's my integral. This integral is the integral of u with respect to v, like so. And therefore it equals this, uv minus the integral of v. I know I write dv dx. I actually think I should probably write just v dashed here so I don't confuse you. I'm sorry if you're taking notes. That's v dashed, and this is u dashed. So let's put those in carefully. U is x, v is negative sine x, minus the integral of v negative sine x, u dashed was 1, like so. And because u dashed was so simple here, it's very easy to integrate. So this is negative x sine x, minus of a minus becomes plus, the integral of sine x dx. And that is negative x sine x plus, well, what's the integral of sine? It's negative cos. My sine's going a bit bad at the moment. Minus cos x plus constant. And see, that integration constant is going to come at the end. Don't worry about it up here. Let's try another. The integral of x times the square root of x plus 1. Again, it would be difficult to find a substitution here, so integration by parts is probably our best bet. Which way should we do it? Let's use the same trick. This is very easy to differentiate and becomes much simpler. So let's make that u. Let u be x and v dashed be x plus 1 to the half. Now I've deliberately changed my square root to a half because I'm about to integrate it and this will make it easier. So u dashed is 1 and v is increase the power x plus 1 to the 3 on 2 and divide by the new power, divide by 3 on 2. I'm just going to simplify that a little bit. 2 x plus 1 to the 3 on 2 over 3. I've just simplified that division by fraction. Okay, let's apply the rule for integration by parts. My original integral is the integral of u v dashed dx. So it becomes uv minus the integral of v u dashed dx. Substitute carefully. U is x, v was this, 2/3 x plus 1 to the 3 on 2 minus the integral of v, same horrible looking thing, 2/3 x plus 1 to the 3 on 2 times u dashed, which is 1 dx. And that's okay. I can integrate this because the inner part is linear, so its derivative is 1. So that's going to be easy. This is 2/3 of x plus 1 to the 3 on 2 minus the integral of this, it's 2/3 of something. Well, this becomes x plus 1 to the 5 on 2 divided by the new power 5 on 2. And I would have to divide by the coefficient of x, but that's 1, plus a constant. Simplify again. 2/3 x plus 1 to the 3 on 2 minus, a little bit tricky to see, this 2 on the bottom here goes up to the top. So I have 4 on 3 x plus 1 to the 5 on 2 plus constant.